Hello everybody, welcome to my HVAC channel, Abu for HVAC. In this video we are going to be looking at chilled water terminal system, types and specifications and more. Here is my profile for you to have more information about me. So let's start part 1 of this series. First of all, please have a look to my profile.
Ibrahim is an OSHRI member. Ibrahim Saleh, Senior Mechanical Engineer, UAE. Ibrahim has been in UAE since 2008. His primary responsibility as a Senior Mechanical Engineer, Senior Construction Manager MEP, more than 16 years of experience. He has filled positions ranged from mechanical engineer to project manager in many projects in UAE with MEP contracting firms, and he has good experience in the supervision and design for residential and commercial building projects applying local and international codes. He has good experience in piping design, pipe stress analysis, engineering software, plumbing, firefighting and chilled water. He is also the author of numerous blogs. Ibrahim is an OSHRI member.
Let's go directly to our topic, chilled water terminal systems. In this program, we will discuss system design and control strategies for various types of chilled water terminal systems, including fan coils, chilled beams, and radiant coolings. Topics include types of terminal equipment, variable speed terminal fan operation, dedicated OA system design, chilled water system design, and complying with ASHRAE 90.1 requirements. Here are the goals of this series. First, after viewing this series, all the attendant will be able to summarize design and control strategies that can save energy in various types of chilled water terminal systems, including fan coils, chilled beams, and radiant cooling. Understand the latest fan motor technology being used in chilled water terminal units. Apply design and control strategies in dedicated OA system as part of a chilled water terminal system. Learn how to design and control the chilled water plant for various types of terminal units. Understand how the requirement of ASHRAE standard 19.1 to chilled water terminal. Here is the agenda of our series. We have to go to look about types of chilled water terminal units, which are fan coils, blower coils, chilled beams, radiant cooling. We have to have a look on dedicated OA system design, chilled water system configurations and control, and last we have the summary of this series. Let's have a look of the types of chilled water terminal units. Types of chilled water terminal units include fan coils, which is blower coils, chilled beams, and radiant cooling. First, this is a fan coil, normal blower fan coil, which has the air intake with filter. Next part will be the filter, the coil, the chilled water cooling coil, and last part will be the fan, the blower fan with the discharge part of the fan coil unit. In any building with chilled water system, we will have a system like that. So we will have the chiller or the plant which is providing the chilled water to the building, and we will have fresh air system, which coming by using fresh air handling unit, and we will have the terminals including the VEVs, the FCUs, all the terminals which inside the building. There is integration between the parts of the system through the building energy management system. Okay, so we are using this system to integrate the parts of other components of our building to be working smoothly and perfectly together. In this system we have fresh air handling unit, we have supply, fresh air supply, and we have exhaust which is coming in the return here. Here we have a heat recovery wheel. Okay, so this is fresh intake, exhaust air, and here fresh air supply, here exhaust return. And we have the terminals in the zones, different zones. We have here, for example, one fan coil unit integrated. It has the chilled water supply and return coming from the plant, from the chiller, and we have the ducts to the outlets, which are the diffusers and the grills. Here we have many types of the chilled water fan coil units. We have various fan coil units style. We have also many types of terminal units, like this is actually floor stand fan coil unit. Here we have stand type blower coil air handlers, many types. We have vertical also stack, we have vertical cabinet, we have horizontal concealed type, which is regular type in many buildings, especially in the villa buildings and high-rise buildings. The role of the fan coil unit is to provide supply air, cooled air to the zones, which is provided with HVAC system. So to perfectly design the fan coil units, it has electronically commutated motor technology. This is actually very important AC motor, and the function of this motor is to convert electrical energy into mechanical energy, like blower. So it will become a blower fan. Fractional horsepower power signal single phase AC motor are relatively inefficient. AC motors are designed to run most efficiently at the rated voltage and speed. Multiple speed capacity has traditionally been achieved with multiple winding taps. Here the fan motor extracted actually to see the internal parts of the motor, which is the rotor, the commutator, and the stator permanent magnet, and there are the very important parts, which is brushes. This actually, the brushes, they are very important in the advanced motor technology. Brushes technology extends motor service life and reduce maintenance. Brushes no longer need to be cleaned, and dust from brushes is eliminates speed restrictions inherent with brushed DC motors. Commutator doesn't carry current to motor, eliminates brushes and their related back drawbacks. Now the motor of the fan coil unit can be constant speed or variable speed. Here is the system configuration for both type of systems. So on the constant speed, it is a conventional constant volume terminal unit control. And there is the new single zone VAV terminal unit control, which is used in the variable speed supply fan. It is totally very good to have more reliability in the system. In this slide, you can see how the ECM with using VAV motors can save more energy than the PSC normal 3-speed motor. So there is more efficiency in saving the power consumption in the VAV ECM motors. Second type of the terminal chilled water terminal units is the chilled beams. We have two types of chilled beams: active chilled beams and passive chilled beams. This slide showing the first type of the chilled beams, which is active chilled beams. The active chilled beams has the coil in the middle, the coils in the middle, and this is the return air from the space, and this is the supply air through nozzles in the chill beam coming to the space. Second type is passive chilled beams. The coil also on the top of the beam, and there is perforated part which is sending the cooled air to the space, and the return coming from back of the beam. Here is another slide showing the both types of the chilled water beams, how they are working. And this is the active chill beam, and this is the passive chill beam. Clearly, okay, you can see how the air is sends, how the air will be sending to the space, and how the return air coming. And here in the passive beam, how the air coming from back of the beam, and how the supply air coming inside the perforated area of the active beam, of the passive beam. Last type will be the radiant cooling. Radiant cooling is a very good method to make cooling or heating for the zones or the space. We have here the coils inside the floor, for example in floor radiant, the coils inside the floor, and this system is using radiation activity to make cooling for the space. It has radiant panels embedded inside the walls or the floor, or also the slab ceiling. What are the major benefits of radiant cooling? First, thermal comfort. Second, improved air quality. And last, chilled operation. How it is thermal comfort? All air HVAC system address surface temperature only directly, which result in surface temperature lagging behind the set point temperature. Radiant cooling permits direct thermal control of active interior surfaces and via radiant exchange between non-active and active surfaces. Improved air quality. Decoupling of primary space cooling loads and OA ventilation offers opportunities to improve air quality. The major reason for this is stratification layer is maintained in the room, and also proper convective currents ensures that the exhaust air moves out from ceiling and fresh air gets cooled with radiant flooring and remains in the breathing zone. Chiller operation. Supply chilled water temperature can be operated at lower temperature, and the reason for that is the floor cannot be chilled to 10 degrees centigrade, thus is necessary to maintain the floor temperature minimum at 18 to 20 centigrade. Since heat transfer takes place through radiation, hence the MRT mean radiant temperature reduces, thus even 27 degrees centigrade room temperature feels very comfortable at the conditioned space. Now, thank you for watching. See you next part of this series. Please like, share and subscribe in my channel. Bye.